Hello everybody, my name is Mihaela Ștefan. I am a professional services engineer at Infinet Wireless. Thank you very much for taking the time to join our webinar. Today we are going to discuss about the Quanta 5 product, a cost-efficient, high-capacity point-to-point solution. Let's check the agenda of the webinar. First, we will overview the key features of the Quanta 5. Here we will understand together the benefits provided by using the Octopus SDR platform. We will learn the radio technologies implemented, we'll state the performance of the product, and we'll also find out the AIR protocol features. Then we will review the hardware versions of the product. Afterwards, I will briefly introduce the physical parameters and some of the configuration options. We'll also see what are some practical applications where Quanta 5 is suited and brings added value. And in the last section of the webinar, we'll briefly review the technical resources that are available for the Quanta 5. Let's begin with the key features of the product. Quanta 5 is based on the new Octopus SDR hardware aimed at increasing the link performance several-fold. So first, let's see what we mean by software-defined radios. Traditionally, the processing modules of a radio communication system were implemented using various hardware, like mixers, filters, modulators, detectors, and so on. With a software-defined radio, all these features are now implemented in software by handing over significant amounts of processing to a general-purpose processor. This way, many different radio protocols or features can be served by and added to the software-defined radio by simply customizing the software that is used. We conclude that Quanta 5 is fully future-proof, as new physical, MAC, and upper layer features can be added through a simple firmware upgrade, even for the units that are already operating in the field. Addressing challenges such as limited spectrum availability, growing interference challenges, and demands for yet more capacity, Quanta 5 combines the best features from the well-proven other Infinet Wireless families, as well as numerous cutting-edge wireless breakthrough technologies. Let's check some of the innovations implemented by the software-defined radio. First, we have the per-stream automatic modulation control. Most wireless systems have a common automatic modulation control. This means that no matter which channel is affected by interference, the modulation decreases in both. In order to maximize the performance, we've created a more flexible and smarter AMC algorithm. Quanta 5 can select the appropriate modulation and coding scheme for each polarization and for each end of the link independently. When there is no interference, or if the interference has the same power in both polarizations, the effect will not be noticeable. But in situations where the interference has an imbalance in power, channel-based AMC will save from 25 to 62% of the performance. Another approach in mitigating the effects of interference is the mechanism of resending lost data. This solution is based on the assumption that the interference has a probabilistic behavior. Consequently, if we repeat the lost pieces of information, the likelihood of recovering it is very high. This allows the system to maintain higher order modulations. So by using ARQ, we increase the chances of error-free operation on high modulations. Next, Quanta 5 uses the single carrier frequency domain equalization modulation for transmitting the data. The modulated symbols are sent in the time domain on a single carrier, and the equalization performed at the reception takes place in the frequency domain. This type of modulation has the advantage that the peak-to-average ratio of the transmitted signal is low, opposed to the OFDM signal. so the amplifier at the reception is easier to implement and less expensive. Moreover, single carrier FDE performs similarly to OFDM, but has the advantage that for certain types of fading, it offers better quality. When the transmission conditions deteriorate, the signal is affected and cannot be correctly demodulated at the reception. In this case, the transmission system is responsible by taking several actions, of which an important one is to reduce the order of the modulation. Usually, if more than 1% of the whole capacity is lost, then the modulation encoding scheme is going to be decreased. In conventional communication systems, one modulation step is approximately equivalent to 60 megabits of capacity in the 40 megahertz band. In order to avoid wasting so much capacity, we have increased the number of the available modulation levels up to 14. With this enriched set, the modulation step of adjustment has been reduced to 30 megabits per second instead of the 60 megabits per second. Next, let's review the radio technologies of the Quanta 5 product. So Quanta 5 is a wireless point-to-point solution in the 5 gigahertz spectrum. The product offers a unique combination of high performance, affordability, and easy installation, targeting a vast range of applications. The transmit power goes up to 27 dBm. We mention here as important as well that the maximum transmit power at the highest modulation is one of the key performance metrics, allowing Quanta 5 to achieve the highest performance over long distances and in noisy environments. The Quanta 5 transmit power at QAM 256 is up to 24 dBm, which is one of the best in the wireless marketplace today. Notable as well is the receiver sensitivity that goes down to minus 100 dBm, a very low level at which signals can be heard by the receiver. There are two models available, one having a dual polarization integrated antenna with an antenna gain of 23 dBi, and another having two N-type connectors for connecting an external antenna using low-loss RF cables. Quanta 5 has a link budget of up to 168 dB. This budget allows it to achieve reliable connectivity at up to 40 kilometers in clear line of sight conditions. It also provides sufficient margin for near and non-line of sight deployments at shorter distances. There are multiple options for choosing the channel width. This is particularly useful in case of interference that overlaps only with a small part of the channel. In classical systems, you will have to reduce the bandwidth to half, so the capacity as well is reduced to half in order to be able to remove the effect of the interference. With Quanta 5, you can adjust the bandwidth gradually in order to adjust to the specific scenario and achieve a minimum capacity reduction. Let's next assess the outstanding performance of the unit in terms of capacity, processing power, and transmission quality. Quanta 5 features a brand new record-breaking spectral efficiency powered by the impressive capacity of up to 460 megabits per second using only a 40 megahertz channel size. So with a small channel size, we obtained a high capacity, leading to an increased spectral efficiency. The processor can manage 900,000 packets per second, which denotes a performance signal processing capability that can sustain various applications. The latency is very low, between 0.5 and 3 milliseconds one way, which enables full support for real-time applications and a superior transmission quality. Now let's briefly review the air protocol related features. We'll discover here the advanced mechanisms that boost the performance of the radio transmission. As a duplexing scheme, Quanta 5 uses TDD, meaning that the uplink and downlink directions wait for their turn in order to transmit or receive the data. However, the hybrid FDD or split frequency mode allows choosing frequencies for the uplink and downlink channels independently. So it is likely that you will see the different frequencies being used for uplink versus downlink, depending on the interference level at each end of the link. The airframe duration can be chosen between 1 millisecond to 10 milliseconds. You just have to keep in mind that the balance between the throughput value and the latency value. By using a longer frame size, you increase the capacity, but the latency increases also. Therefore, depending on the type of application that you require, you must choose an appropriate airframe duration. Short sizes are used for real-time applications, and longer frame sizes are used for internet data, for example. Instant DFS represents a set of algorithms operating on top of the mandatory DFS and radar detection, providing background spectrum scanning and zero downtime channel reselection in case of congestion or radar detection. The unlicensed spectrum implies availability for any operator. This means that the noise and interference levels will constantly change over time. The instant DFS mechanisms allows the system to operate on the clearest channel by constantly monitoring the spectrum in the background and switching to the least interfered one. Instant DFS is not currently implemented, but it is a roadmap item that will be included shortly to Quanta 5. The uplink-downlink ratio is configurable from 50% to 90-10 ratios in any direction. This is particularly useful for asymmetric traffic demands, like in the case of a CCTV that requires full capacity in the uplink. As we discussed when operating in highly interfered environments, Quanta 5 dynamically selects the most suitable modulation and coding scheme for each polarization and ensures the delivery of all transmitted packets using an advanced AirQ algorithm. The data transfer takes place seamlessly with the proper quality in any type of external conditions, from harsh environment interference or lack of visibility. Next, we have the automatic ranging features, which is responsible for estimating the distance of the link. Being a TDD system, the reception has to wait for a specific amount of time upon receiving data, and all the calculations are done automatically. Let's now review the hardware unit. Mounting kit 85 is supplied with the device by default. It allows to perform reliable and easy installation of the unit with 2-axis adjustment. The mounting is carried out on a pole with a diameter between 30 and 85 millimeters. There are also possible options for mounting on a wall or pole with a different diameter. The LED panel includes the power indicator, which is yellow when a 10 or 100 megabits per second wired connection is available, or green when the 1 gigabit connection is available. The other indicators are used to show the signal strength for an easy antenna alignment, and the more indicators are on, the better is the wireless connection. The RJ45 socket is used for connecting to the power supply and to the network as well via the power over Ethernet power supply. The network connection to the ODU is made using 1 gigabit Ethernet connection, and the power is provided to the ODU or to the Quanta 5 unit over the Ethernet using a standard IEEE 802.380 passive power over Ethernet power supply. We can now see the Q523 model with an integrated antenna of 23 dBi gain. The other model is Quanta 5e the connectorized version, where an antenna has to be connected using the N-type connectors. The units are compact and have a small form factor that allows an easy integration in any setup and scenery. Moving on to the physical parameters, Quanta 5 operates in a vast range of temperatures from -40 to +60 degrees Celsius. The units feature water and dust protection in compliance with the IP66 and IP67 standards. Quanta 5 is operational under wind speeds of up to 160 kilometers per hour. In conclusion, the robust weatherproof enclosure offers reliability in any type of environment. Let's focus now a bit on the configuration options. Quanta 5 has a newly designed web interface, which allows you to check the status of the unit, perform configurations, and conduct troubleshooting in a very intuitive manner. You can see here a snapshot with the dashboard of Quanta 5 showing information about the modulation and coding scheme used in each direction and for each polarization, the RSSI levels for each chain as well, along with EVM and ARQ indications. You can also review the radio configuration settings of the unit from this main menu. Spectrum Analyzer is a very useful tool in assessing the level of interference on the spectrum range of interest. The tool performs a complete scan and offers information about the signal level of the interference detected. This way you can easily determine the external interference conditions of the radio link. The graphical antenna alignment tool allows to visualize the signal characteristics on both sides of the link in order to make the antenna alignment process more accurate and easier. It helps to find the best antenna position via comparing the actual received signal level with the calculated reference value. When the measured signal level is close to the reference value, the square indicating the signal level becomes green and shows you that the alignment is proper. So now that the signal level is yellow, the alignment is not proper. You should see the square becoming green. Next, Quanta 5 has full support for VLANs, which is useful for traffic isolation and filtering. Additionally, STP can be used to avoid loops in the network. Stacked VLAN support, or Q-in-Q, avoids the limitation in the number of available VLANs, which can be useful for large networks. In addition, Q-in-Q allows you to organize layer 2 channels within a limited VLAN list, which is widely used in provider networks. As QoS features, we mentioned that the unit has 8 priority queues for packet filtering and performs classification based on 802.1p priorities. 1588 version 2 synchronization through the Ethernet network is a roadmap item for Quanta 5 pending implementation. Synchronization is very important, as you know, because it allows you to use collocated devices with the same frequency or with a limited set of frequencies. Let's now review some of the applications where Quanta 5 is best suited. First, we have the connectivity of remote locations. Infinet Wireless systems are ideally suited for creating large citywide or regional transport networks and have been deployed many times around the world in campus-style topologies or for the connectivity of distant company branches and warehouses. Quanta 5 supports distances of up to 40 kilometers without loss of quality. Diverse services have to be delivered over reliable high-capacity networks, and Quanta 5 can successfully meet the challenges of the task. Next, we have the connectivity for the mobile operators and service providers. The harsh competition has created a vital need to reduce the network costs while delivering robust, high-quality services. Using Quanta 5, the operators can meet their customers' growing needs for bandwidth, mobility, and better coverage. Additionally, Quanta 5 offers reduced operational and installation costs thanks to faster and simpler installation procedures that do not dictate line-of-sight conditions. The communication is also possible in case of no direct visibility for the link. Thanks to the low latency and jitter, along with the vast networking features set, Quanta 5 offers support for triple play services, which is very useful in this particular case. Temporary links which serve a specific task or event can easily be implemented using Quanta 5 equipment. The deployment process is very fast, starting with an immediate shipment from the warehouse and continued with an easy, straightforward installation aided by intuitive graphical tools. At a very efficient cost, you can benefit also of a high-performant equipment that can be used in various scenarios. Another good practice is to use backup links, for which Quanta 5 is one of the best candidates. So if you require a redundancy link for a specific sensitive link, you can easily integrate the Quanta 5, which offers high capacity, reliability, and fast installation. For additional detailed technical information about Quanta 5, we have available the documentation on our website, where you can find the technical manual with detailed information. You can also join our online courses at the Infinet Wireless Academy to learn more about our products and technologies. An important tool that you can use is InfiPlanner, our free wireless link planning tool that helps you design point-to-point and point-to-multipoint networks without the need of on-site field surveying or specialized tools. You just need to create the link, specify the units that you are using, then input the parameters of the link. Afterwards, you will obtain a summary report showing you the available throughput, along with additional radio indicators. In conclusion, the unbeatable price-performance ratio makes Quanta 5 the preferred choice for service providers looking for a reliable, noise-immune, high-performing yet affordable, high-capacity point-to-point solution. This brings us to the end of today's presentation. Now, if you have any questions, please feel free to ask them, and I will check the chat section in shortly. Nick is asking if passive power over Ethernet or active 802.380. So we have both options available. You can also use passive power over Ethernet or active 802.380 as you need it, according to your setup. Does Spectrum Analyzer drop the RF link? Yes, currently it interrupts the link when performing the scanning. Another question is, what is the difference between R5000 and the Quanta 5? Well, Quanta 5 is a point-to-point solution, only point-to-point solution, and it offers higher capacity, 460 megabits per second. As I mentioned in the presentation, the main difference actually is in implementation. So R5000 is based on an 802.11 chipset, and the Quanta 5 is based on the software-defined radio, which we call Octopus. So Quanta 5 is fully configurable by our developers, and we can add features and updates to it simply in software. So it is more flexible, and also it brings you benefits because we can modify, as you saw, the modulations. We now have 14 modulations levels, so more modulations available in order to reduce the capacity with the lower step. We have a per stream automatic modulation control. So you have a lot of benefits and improvements in the Quanta 5 compared to R5000, because the software-defined radio allows us to implement many features and many technologies that can boost the performance. You will obtain greater performance with Quanta 5, which is most visible in the throughput value. Another question is if Quanta 5 is supported in InfiMonitor. Currently not, but this is work in progress. So it should take a short time until it is available in InfiMonitor. I come back to Nick's questions about the instant DFS, and currently all the units have one radio module and it will stay like this. During instant DFS channel changing, you will not see an interruption in the link. You will just see the interruption when performing spectrum analyzer. So, so all the implementations, no matter if it's instant DFS or other features, are in software. The unit will remain the same as it is with only one radio, and you will see the changes by updating the software. So for instant DFS, you will not see any link interruption, but for spectrum analyzer, you will see the link interrupted during scanning, also after instant DFS is ready. If we support other versions of Quanta 5 with integrated antennas, with Quanta 5 with 18 dBi is in progress. So we have one more version in progress with 18 dBi. And in other frequencies, yes, we also have in progress some products that will be available probably next year for 70 gigahertz. Okay, if I buy Quanta 5 today, how do I upgrade to Quanta 5 with the instant DFS? You do not have to change anything for the unit. So if new features are added, you do not have to change the hardware. You just have to update the software, because it's a software defined radio and everything is software. No hardware modifications from now on. Do we have Quanta 5 operating in 6 gigahertz? No, only up to 6 gigahertz. So it's 5 gigahertz spectrum, like we said in the presentation. You can see the range. One last question I see, if Quanta 5 has been forming. No, Quanta 5 is a point-to-point product, so it does not have been forming. It is not necessary. It is a point-to-point alignment. Nick is saying that having a single radio means it cannot move channels without performing channel availability check. Yes, it constantly performs channel availability check, but it is only done when no data is being transmitted in a very short frame time. So you will not lose connectivity with the unit, and you will also not see the link interrupted, because everything is performed in between transmissions, and you will not notice any interruption. It will not affect the throughput in any way. Okay, I reviewed and I see only 2 more questions that are not answered. Can the Quanta 5 be powered by a power over Ethernet switch? Yes, of course. Basically, all the units can be powered using a power over Ethernet switch. For the MISO mode, you cannot use them in MISO mode. The product is similar to XG, where you cannot disable the chains. You can disable the chains only for R5000. The Quanta 5 is similarly to XG. So you cannot disable one chain and you cannot use them in MISO mode. Oh, and if Quanta 5 supports CLI configuration, yes, all the units support CLI configuration. Okay, so I hope that everything is clear. Basically, what you have to keep in mind about Quanta 5, it is that it is a software-defined radio. So if you buy the unit, the hardware will remain this way. No change will be performed in hardware in the future. So all the changes that we perform, when we say that we will add something, we mean that the feature will be added in software. And when you upgrade the firmware, you will benefit of the latest features. No, Quanta 5 does not have SFP ports, another question. Maximum capacity is 460 megabits per second. So this is similarly to XG, but it is at a better cost. Thank you once again for your time, and I hope we will meet again during our webinar next month. Have a nice day, everybody.